Hello, welcome to the Week 5 video tutorial for the mathematical problem in Chapter 9. I would like to emphasize that this is a very similar problem to what's been assigned to you, but it is not the same problem. So please don't turn this problem in. You'll need to work the Chapter 9 problem out using these same steps. So our problem says the production function is Q equals AL to the 8th power, if that's a thing, times K 1 minus A, where A equals greater than 0. Okay, so what the heck does this mean? Q, take it bit by bit, Q is the maximum output, which we can also call production. AL to the 8th power, or to the power of A, is average labor. AL, average labor. K is capital. You can remember this by misspelling capital. Spell it with a K. But it's capital to the power of 1 minus A. And again, A is just some number that's greater than 0. Okay, so what does this mean? In a nutshell, it means our production function is maximum input, which again is Q, and Q is equal to the average labor times itself, some indeterminate amount, which is A. We know that A is greater than 0. That's the only thing we know. When we take that number and we multiply it by our capital to its power, and the powers are going to be assigned differently on each problem, but basically it's Q equals average labor times capital, and the powers are the units. So we don't know what the unit is, but we know that it's greater than 0. So the first question that we're asked, and before we go there, I probably ought to point out that the book very clearly states that there's a lot more considerations than labor and capital, but it requires advanced calculus to do it. So I just want you to know that this exercise is just to illustrate at the very simplest level how you can estimate production. Don't expect anybody to do advanced calculus. So let's go back to our problem, which is the production function is Q, or production, equals average labor to the power of units of average labor times capital to the power of its units of average capital. So marginal product of labor. And remember, when we work in the margins, we are looking at what would happen with one additional unit. What would one additional unit do to our circumstances? So that means our marginal production of labor equals, and this is subscript, A, which is our unit, times AL, average labor. And see up here it was A, but we're changing it to, we're going down a unit, A minus 1 times capital, and we're leaving that as 1 minus A. And let's make these superscript so that we all know what we're talking about. Okay. So this is our marginal labor. And we do the reverse to find the marginal product of capital, the MP subscript K. And what do I mean by that? MP P K equals, oh, I lost this. Oh, yeah. A minus 1, average labor, to the power of A, times K, 1 minus A. Oh, minus 1. So we're changing it by 1. So as you can see, the differences between the marginal product of labor and the marginal product of capital is really just the arrangement of the math. And we're changing 1 unit on each side. On one side, we're changing labor. On the other side, we're changing capital. So the marginal rate of technical substitution, MRTS. This basically tells us when we increase or decrease our labor or our capital, what does that have? What effect does that have on our rate of technical substitution? So to go back to the original thing that we were talking about, is the maximum output is average labor times to the power of its unit multiplied by capital to the power of its unit. And when we work in the margins, we're seeing what difference 1 makes. So MRTS, marginal rate of technical substitution, equals the unit of labor, which again is A, times, or I'm sorry, divided by the unit of capital times labor. And that hopefully makes sense. I know it's kind of backwards, but again, labor and capital, what we're doing when we try to find the marginal rate of technical substitution is we are looking at the units of its companion. So the companion of capital is labor and vice versa. So we're looking at the labor units times capital, and we're dividing it by capital units times labor. So D says show that the isoquants for this production function are convex. So it's not asking if they are convex, it's asking us to show that they are convex. And its hint is show that MRTS diminishes as labor increases, and why. Well, we know that increasing our labor will cause our marginal rate of technical substitution to decrease. The reason that's the case is that the marginal rate of technical substitution is a positive number. So the way that we look at this, and we demonstrate, we're going to show, is we look at the derivative, which in your book it'll be that curly D. So it's derivative of MRTS divided by the derivative of labor equals negative units of labor times capital divided by capital units times labor. Sorry, squared. Let's make this a superscript. And the reason we're squaring it is because we're working with derivatives. Okay. Speaking of derivatives, the next thing is to derive the equation for the long-run expansion path. So, we're still working with MRTS. We're working with W and R, as explained in your book. And we're still working with capital and labor. So, MRTS equals W divided by R, which equals the units of labor times capital to its most efficient divided by the units of capital times labor to its optimum number, which, if we want to add the extra step in here to point out, is still W divided by R, which also equals I need a bracket for this, sorry, equals the units of capital times W divided by the unit of labor times R times labor to its optimum number. So what we're saying here is, let me just make that, close that off. What we're saying is that the optimum amount of labor and capital can be expressed by taking our W and our R and dividing our R into our W. No matter what our W is, no matter what our R is. we're always working with the units of capital, the units of labor, and by by figuring the marginal output, we're figuring out what the optimum number is. We don't have real numbers, so we can't really do the equation, but this is what it looks like. I know this one hasn't been very long, and since we're not working with actual numbers and we're working with abstract concepts, it might be a little bit confusing. If you have questions, ask me. I'm happy to help, and I look forward to reading your papers. Talk to you soon.